Hello, and welcome to another gentle journey on Sleepy Professor Stories. Tonight, you are invited to drift into a story that moves far more slowly than your day ever needs to. We are not meeting dolphins as they leap through modern waves or glide beside boats. Instead, we are traveling backward through layers of time so deep they feel almost like quiet water itself. Long before sleek fins and echoing clicks, long before the open ocean became a home, there were small land mammals stepping carefully along warm shorelines. Their world is softer than you might imagine. Forests breathing under ancient skies, shallow seas pressing gently against sandy edges, life unfolding without hurry. This evening, we will follow that gradual unfolding. We will watch bodies shift in subtle ways across millions of years, see limbs reshape, hear how sound becomes a guide through dark water. Evolution is not a dramatic leap. It is a patient conversation between environment and survival, repeated over generations, so numerous they blur into calm continuity. And as we explore this slow transformation, you may notice that the rhythm of it begins to feel almost like breathing, steady, quiet, unforced. If you enjoy these slow explorations, you're always welcome to like, subscribe, or share your thoughts below. It simply helps others find this calm space too. But for now, there is nothing you need to do right now. No facts to memorize, no tests to pass. Just breathe slowly. Let your shoulders soften. Allow the day to drift further away. The past is vast and unhurried. It will wait for you. Let's begin. Long before the smooth curve of a dolphin's back rises through blue water, long before echoing clicks travel through the sea, there is land. You find yourself standing in a warm, ancient world where forests stretch wide and rivers wander lazily toward shallow coastal waters. The air is thick with green growth, and the continents rest in shapes slightly unfamiliar, still drifting in their patient dance. This is a time after the great reptiles have faded, when mammals are quietly spreading into new roles across the earth. The ocean is present, vast and shimmering, but it is not yet a home for creatures like dolphins. For now, it is simply a boundary, a breathing edge between worlds. In these forests and along these soft shorelines walk small hoofed mammals, distant relatives of many species alive today. They are not large, not dramatic, not especially powerful. They move with careful steps, their bodies supported by 4 sturdy legs, their weight balanced over cloven hooves that press gently into damp soil. Their skeletons are built for land, with flexible spines and strong limbs that carry them through undergrowth and across muddy banks. Their lungs draw in warm air, expanding and releasing in steady rhythm. At this point in history, their lives unfold entirely on solid ground, shaped by the textures of earth and leaf and bark. If you imagine watching them, there is nothing urgent about their movement. They graze on low vegetation, nibble tender shoots, and pause often to listen. Their ears are tuned to the rustle of predators and the calls of others nearby. Inside their skulls, small bones carry vibrations from the air toward delicate inner structures, translating sound into awareness. These hearing systems are designed for a world above water, where sound travels differently than it does in the sea. Every part of their anatomy reflects this terrestrial life. There is no hint yet of blowholes or flippers, no smooth torpedo shapes, only fur, hooves, and the quiet steadiness of land mammals thriving in a recovering world. The climate of this era is warmer than what you know today. Polar ice is minimal and shallow seas spread across continental edges. Along these coastlines, tides roll in and out with gentle persistence, creating wetlands and estuaries rich with life. Fish gather in these protected waters. Crustaceans move through reeds and mud. The boundary between land and sea becomes a place of abundance. For mammals living nearby, this edge offers something new. Food that is not rooted in soil, but swimming just beyond it. The shoreline does not demand change. It simply presents opportunity, waiting patiently. You can picture one of these early mammals stepping closer to the water's edge. At first, perhaps it only drinks. Cool liquid laps against its muzzle. Over time, some individuals may wade in slightly, their hooves sinking into soft sediment as they reach for plants growing in shallows. Their bodies are still fully suited to land, but they are capable of paddling briefly if needed. Many modern hoofed mammals can swim when required, moving their legs in simple strokes. In this ancient setting, such behavior is not unusual. It is simply flexibility, a quiet extension of what their bodies already allow. Inside their cells, variation is always present. No two individuals are exactly the same. Small genetic differences influence limb proportions, skull shape, ear structure, and countless other traits. Most of these differences change little about survival. But in environments where food is plentiful near water, even slight advantages matter. A slightly stronger tail for balance in mud, a marginally denser bone that helps steady the body in shallow currents. These are not dramatic transformations. They are whispers of possibility carried forward through generations. The continents themselves contribute to this unfolding. As tectonic plates shift, coastlines alter and inland seas appear or retreat. New habitats form gradually over thousands and millions of years. Mammals living near these dynamic edges experience environments that are never completely still. Floodplains expand. Rivers carve new paths. Lagoons deepen. Change is constant, but slow enough that life adjusts step by step. There is no sudden leap from forest to open ocean, only incremental exploration along watery margins. You might notice how gentle this process feels. Evolution does not plan ahead. It does not rush toward dolphins as a goal. It responds only to present conditions. When a shoreline provides reliable food and relative safety, some mammals spend more time there. When individuals who tolerate water slightly better find greater success, their traits quietly spread. Over immense stretches of time, small tendencies accumulate. Bones shift position by fractions. Muscles strengthen in new ways. Sensory systems adapt to subtle pressures. For now, though, these mammals still sleep beneath trees. They give birth on land, nurse their young in sheltered clearings, and rely on air to fill their lungs. Their nostrils sit at the front of their snouts, perfectly placed for grazing. Their spines flex for running rather than swimming. If you were to see them, you would never guess that their distant descendants will one day glide through open seas with effortless grace. And yet, the connection is already present, hidden within shared ancestry. There is something calming in this thought. The extraordinary often begins in the ordinary. A dolphin's sleek body traces back to creatures that once stepped carefully through mud. No leap is required, only time. If you feel your breathing slowing as you imagine this ancient shoreline, that is natural. There is nothing you need to solve here, nothing to hold tightly. Just the image of warm light over shallow water and small mammals moving without hurry along its edge. As generations pass, certain lineages spend more moments in wetlands and estuaries. Their diets expand to include aquatic prey. Their senses begin ever so slightly to accommodate a world where sound behaves differently and movement through water requires new coordination. These shifts are still subtle, almost invisible against the vast canvas of time. But the shoreline continues to offer its invitation. And so, this chapter closes not with a splash, but with a pause. Land still anchors these mammals, yet water grows more familiar with each passing age. The boundary between forest and sea becomes less of a line and more of a meeting place. In that quiet meeting place, something begins to lean forward, as if listening to the rhythm of waves, are preparing, without knowing it, for the first true steps toward water. The shoreline no longer feels like a distant boundary. It feels closer now, more familiar, as if the land itself is gently leaning toward the sea. You can imagine the same small hoofed mammals from before, still grounded in forest and meadow, but spending longer moments near tidal flats where river meets ocean. The air carries a faint scent of salt. Mud holds the imprint of careful steps. Nothing dramatic has changed, and yet something subtle is beginning to unfold. These mammals are still creatures of land. Their limbs remain strong and weight-bearing, their backs shaped for walking rather than swimming. But when tides recede, shallow pools remain behind, glistening under warm light. In these pools move small fish and soft-bodied creatures, easy to catch for an animal willing to wade a little deeper. You can picture one stepping cautiously forward, hooves pressing into cool sediment, water rising along its legs. It does not dive. It does not commit to the sea. It simply explores. Water offers new nourishment. Aquatic plants grow thick near estuaries. Schools of fish gather in protective shallows. For mammals living at the edge of this abundance, expanding their diet even slightly provides a quiet advantage. Those that tolerate wet fur, shifting footing, and the resistance of water find access to food others ignore. Over generations, these small differences accumulate. Bodies that balance more easily in slippery mud or paddle more efficiently during short swims pass those traits onward. Evolution works through repetition, not rush. If you listen closely, you may sense how gradual this is. There is no sudden transformation. The skeleton remains fundamentally terrestrial, yet tiny shifts begin appearing. The density of certain bones grows heavier in some lineages, helping steady the body in water and reduce buoyancy. A heavier skeleton allows better control when partially submerged, preventing the animal from floating awkwardly. This subtle change does not hinder life on land, but it quietly supports time spent in shallows. The spine, too, plays its part. While still suited for walking, its flexibility allows gentle undulating motion during swimming. When these mammals paddle, their limbs move in alternating strokes, much like many land animals today. It is not graceful by ocean standards, but it is functional. The water does not demand elegance. It only requires persistence. Each short swim strengthens coordination between muscle and movement, refining patterns that may later become more specialized. Hearing remains tuned primarily to air, yet coastal environments expose these animals to new acoustic experiences. Sound behaves differently in water, traveling faster and carrying vibrations through fluid rather than air. At this stage, their ears are not yet adapted for underwater listening. but some structural variations in skull and ear bones begin to matter. Slight changes in bone thickness or positioning can influence how vibrations are transmitted. Over long stretches of time, these variations will become more pronounced, laying groundwork for future adaptations. For now, they are only faint possibilities. Breathing remains unchanged. Nostrils sit at the front of elongated snouts, perfectly positioned for grazing and sniffing. When wading, these mammals lift their heads slightly higher, keeping airways clear while their bodies are partially submerged. This posture becomes common among individuals who forage in shallow water. The act of raising the head while standing in water is simple, but repeated often, it shapes behavior and balance. Behavior, in turn, can influence which anatomical traits are favored over time. The coastline itself continues to shift. Tides rise and fall daily, carving channels and depositing sediments. Over centuries and millennia, sea levels fluctuate with global temperatures. Wetlands expand and contract. For mammals living at these edges, flexibility becomes valuable. Those comfortable in both dry forest and shallow lagoon navigate changing landscapes more easily. Adaptability becomes a quiet currency, traded across generations. As you imagine these scenes, you may notice how peaceful they feel. There is no chase, no sudden plunge into deep water, only patient experimentation. An animal steps in, steps out, returns again the next day. Its young observe and imitate, learning that the shoreline is not something to fear. Over time, curiosity softens into routine. What was once an occasional venture becomes a daily pattern. Inside their bodies, muscles that assist with paddling strengthen slightly in certain individuals. Tails, though still modest and land-oriented, help with balance and subtle steering when swimming short distances. Even small improvements in propulsion make wading more efficient. Efficiency means less energy spent, more nourishment gained. Natural selection does not reward boldness alone. It rewards balance between cost and benefit. There is something comforting about how understated this transition is. The ocean does not claim these mammals in a single sweeping motion. Instead, it invites them gently, offering food, relative safety from some land predators, and ecological space not yet crowded. Some predators hesitate to enter deeper water, giving semi-aquatic foragers a moment of refuge. Safety, like nourishment, becomes another quiet incentive. You may feel your own body relaxing as you picture this ancient coast. The rhythm of tides mirrors breathing, in and out, forward and back. There is nothing you need to calculate, nothing to remember precisely. Just the sense of gradual leaning towards something new. Over immense stretches of time, lineages that spend more hours in water begin diverging from strictly land-bound relatives. Their limbs, though still weight-bearing, show subtle proportional shifts. Ankles and toes adjust to distribute force differently in soft substrates. The shape of certain joints reflects repeated movement through resistance rather than across firm ground. Each small anatomical variation is preserved only if it proves useful. Many changes fade, a few remain. The story unfolding here is one of patience. Evolution does not anticipate dolphins slicing through open seas. It responds to mud, to fish in tidal pools, to shifting coastlines. Step by step, generation by generation, these mammals grow more comfortable at the water's edge. Their lives become intertwined with tides. And as this chapter settles, you can sense that the shoreline is no longer merely a boundary. It is becoming a bridge Land still anchors these creatures, yet water grows less foreign with each passing age. Somewhere in this slow dance between hoof and wave, a lineage is beginning to favor the shallows more than the forest. In the next quiet stretch of our journey, we may meet one of those early explorers whose body carries clearer signs of this change. A creature whose bones and ears begin to whisper more distinctly of water. The shoreline grows quieter now, as if it senses something important is about to be revealed. You are still standing in that warm, ancient world where rivers slide gently toward shallow seas and mammals wander between forest and water. But among them, one lineage begins to look just slightly different. Not dramatic, not yet fully changed, just enough that, if you linger and observe, you can see that evolution has begun shaping something new. This creature is known to us as Pakicetus, an early relative of whales and dolphins. If you picture it, you would not immediately think of the ocean. Its body stands on 4 legs, capable of supporting its weight on land. Its proportions resemble those of a medium-sized wolf or large dog, with a long snout and a body built for walking. It moves across riverbanks and coastal plains with confidence. To the casual eye, it is still very much a land mammal. And yet, when scientists examine its fossilized skull, they notice something subtle but profound. Deep within the ear region, the bones show a distinctive structure found in later whales. A thickened area of bone surrounds part of the middle ear, forming a kind of acoustic shield. This feature, called the involucrum, becomes a hallmark of whale ancestry. Even here, in this land-dwelling animal, the blueprint of future ocean listening is already present. You can imagine how sound behaves differently near water. Vibrations move through air in one way, through water in another. For an animal spending time along rivers and shallow seas, sensitivity to both environments may become valuable. Pakicetus likely still hears primarily through air, but its ear structure suggests an increasing specialization. The skull bones are dense in certain areas, helping isolate sound vibrations and possibly preparing the ear for more efficient transmission through fluid. It is not yet an underwater specialist, but the architecture is shifting. Its eyes remain positioned for life above the surface. Its nostrils sit at the front of its snout. Its limbs are long enough to carry it over land. But its teeth tell another part of the story. Sharp and suited for catching fish, they suggest a diet that includes aquatic prey. When you imagine Pakicetus near a riverbank, you can see it lowering its head toward the water, scanning for movement beneath the surface. Fish flicker through shallows, a quick snap of jaws, a splash. The boundary between land hunter and aquatic forager begins to blur. Its bones also offer quiet clues about behavior. The density of its limb bones suggests time spent in water. Heavier bones can reduce buoyancy, helping an animal stay submerged more easily. This does not mean Pakicetus lives entirely in rivers, but it likely wades and swims with growing comfort. The shoreline is no longer simply a place to drink. It is part of daily life. There is something gentle about this stage of transition. Pakicetus does not abandon land. It does not rush toward the open sea. Instead, it occupies both realms. It rests on solid ground, gives birth there, and moves across terrain with stability. Yet it returns to water repeatedly, drawn by food and perhaps by safety from certain land predators. This dual existence creates selective pressures that slowly favor individuals better suited to aquatic movement and hearing. As generations pass, small variations accumulate. In some individuals, the ear bones transmit sound slightly more efficiently through dense tissue. In others, limb joints allow smoother paddling. None of these changes appear dramatic in a single lifetime, but across thousands of generations, they layer gently upon one another, like sediment building along a riverbed. You might notice how calm this transformation feels. Evolution is not a leap, but a leaning. Pakicetus stands as a moment in that leaning, a snapshot of possibility. It carries land firmly beneath its feet while quietly preparing its descendants for deeper water. There is no urgency in this process. The earth turns, rivers flow, traits that offer advantage simply continue. Inside the skull of Pakicetus, the arrangement of bones around the ear begins separating the ear region from the rest of the skull in subtle ways. This isolation helps prevent vibrations from the jaw or skull from interfering with incoming sound. Later, whales and dolphins refine this trait, using specialized fat channels in their lower jaws to conduct sound underwater. Here, the earliest structural groundwork appears. A listening skull begins to take shape. If you imagine holding that ancient skull gently in your hands, you would see nothing flashy, just bone, weathered by time. But within its curves lies evidence of a lineage shifting direction. The ocean is no longer distant in evolutionary terms. It is becoming integrated into survival. You may feel your own breathing steady as you picture this ancient creature moving between worlds. There is nothing you need to analyze. Simply allow the image to settle. A four-legged mammal standing at the edge of a river, ears attuned, senses alert, body balanced between forest and water. Pakicetus still sleeps on land. It likely rests in vegetation near freshwater sources, its young nurse beneath open skies. Yet every trip into water reinforces new behaviors. Each fish caught strengthens the connection between lineage and liquid habitat. Natural selection does not plan for dolphins leaping through waves. It favors whatever works in the present moment. And what works increasingly involves water. The skull adapts first in noticeable ways because hearing becomes essential in environments where vision is limited. Murky rivers and shifting currents make underwater visibility unreliable. Sound, however, travels efficiently. An animal capable of detecting vibrations with greater precision gains awareness of prey and surroundings. Even partial improvements can mean better survival. So Pakicetus stands as a threshold figure. Land remains familiar, but water grows less foreign. The ear begins its transformation before limbs fully relinquish their terrestrial role. A listening changes before swimming does. As this chapter softens toward its close, you can sense the balance tipping ever so slightly. Limbs still carry weight confidently on solid ground, yet skull and bone whisper of deeper immersion. The shoreline is no longer simply explored, it is inhabited. And somewhere in the slow passage of generations, another descendant will take this balance further, stepping not just into water, but beginning to belong to it. The shoreline feels different now. The air is still warm, the rivers still slide patiently toward the sea, but the balance between land and water is shifting. You can sense it in the posture of the animals who linger here. Among the descendants of earlier shoreline explorers appears a creature whose body tells a clearer story of transition. This is Ambulocetus, a name that means walking whale, and as you picture it, you begin to see how evolution moves not in leaps, but in long, quiet stretches. Ambulocetus still carries 4 limbs, each strong enough to bear weight on land. Yet its body is longer, lower, more streamlined than its ancestors. The proportions hint at something different. Its spine undulates more fluidly, allowing movement that resembles the rising and falling motion of modern whales. When it walks, it likely does so with a slightly heavy gait, its limbs spreading outward somewhat, built not only for supporting weight, but for pushing against water. If you imagine it entering a river, you can see how naturally it moves. Its powerful hind legs press backward, propelling the body forward through shallow currents. The tail, thicker and more muscular than before, assists in steering and stabilization. Unlike strictly terrestrial mammals, Ambulocetus is not merely paddling with awkward strokes. Its spine flexes vertically, creating a wave-like motion that pushes against the water's resistance. This undulating movement becomes an early version of the propulsion that later whales refined so elegantly. On land, however, you may sense a slight inefficiency. The limbs are sturdy, but no longer optimized purely for running across firm ground. The body's weight distribution favors time spent in water. It is not that Ambulocetus abandons land completely. Rather, water begins to feel like the more comfortable environment. The shoreline no longer represents a place of tentative exploration. It is becoming a corridor between habitats. The skull continues its transformation as well, and the ear region remains specialized, building upon the structural groundwork seen in earlier ancestors. The bones surrounding the middle ear grow denser and more isolated from the rest of the skull, allowing clearer detection of vibrations transmitted through water. Although Ambulocetus still hears through air, these refinements suggest increasing reliance on aquatic acoustics. Sound in water becomes less mysterious, more informative. You might imagine this creature resting along a muddy bank, half submerged, eyes just above the surface. Its nostrils still sit at the front of its snout, but it has grown accustomed to lifting its head easily to breathe, while much of its body remains underwater. Breathing remains deliberate and rhythmic, lungs expanding with air drawn from above the surface. Unlike fish, it cannot extract oxygen from water. It must return to air again and again. This necessity keeps it tethered to the boundary between worlds. Its teeth reveal another layer of adaptation. Sharp and conical, they are suited for gripping slippery prey. Fish and aquatic animals likely form a significant portion of its diet. The shape of its jaws allows swift closure, minimizing escape in murky water. Vision may assist in shallow areas, but in deeper or cloudier rivers, tactile sensation and hearing play greater roles. Each successful hunt reinforces the advantage of aquatic foraging. The limbs themselves begin shifting in subtle ways. The bones of the feet spread slightly, perhaps aiding in pushing against water. While not yet true flippers, they serve dual purposes, supporting walking and enhancing swimming. This flexibility becomes crucial during this stage of evolution. Specialization is increasing, but versatility remains essential. If you let your thoughts move slowly here, you may notice how gentle this transition feels. There is no dramatic moment when land is forsaken. Instead, Ambulocetus embodies a kind of compromise. It moves between habitats with growing ease, yet it still depends on both. Its young are likely born on land, where gravity provides stability. Nursing happens above water. Sleep likely occurs in sheltered terrestrial spots. But daily activity increasingly involves immersion. The skeleton tells a story of commitment deepening. The vertebrae along the spine allow stronger vertical flexion, supporting the wave-like swimming motion. The pelvis remains connected to the spine. But the emphasis on hind limb propulsion in water suggests that terrestrial locomotion is no longer the sole priority. Bone density remains relatively high, helping counteract buoyancy and allowing controlled submersion rather than passive floating. As generations pass, individuals better suited to aquatic movement gain small advantages. Those that swim more efficiently expend less energy and catch more prey. Over immense stretches of time, these slight differences accumulate. Bodies lengthen further, tails strengthen. The shoreline grows quieter behind them, not because it disappears, but because water begins to feel more like home. You can picture Ambulocetus gliding through a shallow coastal lagoon at dusk. The surface reflects fading light. Its body moves in smooth waves, hind legs pressing, spine bending, tail assisting. There is no rush, only fluid motion, each movement shaped by countless inherited adjustments. Evolution hums quietly beneath the surface. There is nothing you need to hold tightly in this image, just the sense of a body discovering new balance. You might feel your own breathing matching that slow undulation. Inhale, exhale, a gentle rise and fall, like the spine of a walking swimmer moving through water. The shift from land-dominant life to water-centered existence is still incomplete, but the trajectory is clear. Ambulocetus demonstrates that swimming can become more efficient than walking in certain contexts. The water supports weight, reducing strain on limbs. Propulsion through fluid begins to rival movement across soil. Each successful venture into deeper channels strengthens the evolutionary pull toward full aquatic adaptation. Yet air remains essential. Each breath requires a return to the surface. This need shapes behavior profoundly. Unlike creatures fully adapted to aquatic respiration, Ambulocetus must balance dive time with oxygen limits. Its physiology supports moderate submersion, not extended deep dives. This constraint ensures continued contact with both realms. As this chapter settles into quiet reflection, you can sense that the center of gravity has shifted. Land is still present, but water exerts a stronger influence. The walking swimmer stands as a bridge, its body carrying both past and future within its bones. And as we drift gently onward, you may begin to wonder what happens when limbs begin to yield more fully to fins, when propulsion shifts from legs to tail alone, and when the shoreline fades, not as a refuge, but as a memory. And the water feels deeper now, not dramatically so, but enough that the shoreline begins to blur at the edges of memory. You are still following the lineage that once stepped cautiously into tidal flats, that once walked with confidence across warm soil. But something is changing in the architecture of the body itself. The balance between land and sea is tipping further toward immersion, and the skeleton quietly reflects this shift. Imagine a descendant of the walking swimmer gliding through a broad coastal lagoon. Its spine moves in a steady vertical wave, pushing water backward and drawing the body forward with growing efficiency. The hind legs are still present, but they are no longer the primary engines of motion. Instead, they trail behind, contributing less propulsion than before. Over countless generations, individuals whose tails generate stronger thrust gain subtle advantages. The physics of water favors streamlined movement, driven by the body's center rather than by separate limbs pushing outward. Inside the pelvis, small changes begin accumulating. In earlier ancestors, the pelvic bones are firmly attached to the spine, forming a sturdy framework for supporting weight on land. This connection allows efficient walking and running. But as life becomes increasingly aquatic, bearing full body weight on land matters less. The stresses placed on the pelvis shift. Selection no longer prioritizes the rigid support needed for terrestrial locomotion. Gradually, the connection between pelvis and spine loosens. You would not notice this in a single lifetime. But in fossils layered across millions of years, the story becomes clear. The pelvic girdle shrinks and begins detaching from the vertebral column. It remains embedded within muscle, but it no longer anchors the hind limbs to the spine with the same strength. This anatomical separation allows the spine to move more freely in water, enhancing the undulating motion that now drives swimming. The hind limbs themselves respond to this changing emphasis. Bones shorten slightly, joints reduce in size. Muscles that once powered strides across land diminish in strength relative to the increasingly dominant tail muscles. In some species of this transitional phase, the hind legs are still visible externally, though smaller and less robust. They may assist with steering or stabilization in water, but they no longer carry weight effectively on land. You can imagine the sensation of buoyancy reshaping priorities. In water, gravity feels gentler. The body is supported by the surrounding fluid, reducing the need for strong, weight-bearing limbs. Efficiency becomes less about lifting mass against gravity and more about minimizing drag. A long, flexible spine and a broad tail begin to outperform legs in this environment. Natural selection responds quietly, favoring forms that move through water with less resistance. As tails strengthen, vertebrae near the end of the spine grow more specialized. The caudal region expands, providing greater surface area for muscle attachment. This supports the development of a powerful tail fluke in later descendants. At this stage, the tail is not yet the wide horizontal paddle seen in modern dolphins, but its role is becoming central. Propulsion shifts from alternating limb strokes to rhythmic spinal flexion. Meanwhile, the forelimbs remain more stable. They gradually begin transforming into flipper-like structures with elongated bones and reduced joint mobility. Their role shifts from bearing weight to steering and balance. But it is the hind limbs that experience the most dramatic reduction. As their functional importance fades, evolutionary pressure to maintain their full size decreases. There is something almost tender about this relinquishing. The land does not vanish overnight. It releases its hold slowly, as if understanding that transformation requires patience. The lineage does not forget its origins, but it adapts to present demands. You can sense how calm this process feels. Nothing is lost in a single generation. Instead, features once essential become less necessary, and over immense spans of time, they recede. Breathing remains an anchor to the surface. Nostrils still sit near the front of the snout at this stage, though subtle shifts in skull structure are underway. Each ascent for air reinforces the connection between body and atmosphere. Yet beneath the surface, the rhythm of swimming becomes more fluid, more effortless. Inside developing embryos of these transitional whales, hind limb buds still appear briefly, reflecting deep genetic heritage. In modern dolphins and whales, tiny vestiges of pelvic bones remain hidden within the body, silent echoes of walking ancestors. These remnants do not support limbs, but they testify to the long continuity of descent. Evolution rarely erases entirely. It reshapes and repurposes. As the pelvis detaches and hind limbs shrink, balance in water improves. Drag decreases. The body becomes more streamlined and reducing turbulence. Hydrodynamics quietly shapes anatomy. Each movement through water reinforces the advantage of a form driven by spine and tail rather than by legs. You may feel a softness in this transition. The image of limbs fading is not one of loss, but of refinement. Just as trees shed leaves seasonally, bodies shed features no longer needed. There is nothing tragic in this, only adaptation, unfolding at a pace so slow it feels almost like stillness. The shoreline, once central, now lies farther behind. Some members of this lineage may still haul themselves awkwardly onto land for brief periods, but their movements are less confident there. Water offers smoother passage, steadier support. The center of life has shifted. If you allow yourself to rest in this image, you can sense the inevitability of it. A body shaped by water becomes increasingly committed to water. Hind limbs, once tools of survival, become relics. The pelvis, once a sturdy bridge between spine and leg, becomes reduced and free-floating within muscle. Power gathers in the tail. There is nothing you need to hold onto here. Just the quiet understanding that change, when given time, reshapes even the most fundamental structures. What once defined a creature can gently transform into something new. And as this chapter settles, you can almost see the silhouette changing. Legs fading from view, tail widening, spine flexing with greater strength. The land has not been rejected, only outgrown. In the stillness that follows, you may begin to wonder how breathing itself will adapt next, and how the face of these animals will shift as they spend more of their lives beneath open water than beneath open sky. The ocean holds the body now with increasing familiarity. Hind limbs have softened into quiet remnants. Tails carry the rhythm of propulsion, and the shoreline lingers only as distant memory. Yet one bond to the old world remains firm and undeniable: breath. No matter how fluid the movement becomes, no matter how completely the body reshapes for life beneath the surface, air is still required. And so the story turns gently toward the face. You can imagine an early, fully aquatic whale ancestor gliding just below the surface of a calm sea. Its spine rises and falls in steady waves, tail pressing water backward in strong, deliberate strokes. When the lungs begin to empty, it angles upward. The head breaks the surface. Air rushes in. A simple act, but one that shapes anatomy profoundly. In earlier ancestors, the nostrils sit at the front of the snout, perfectly positioned for grazing or snapping at fish near shore. But as time in water increases, lifting the entire head forward to breathe becomes less efficient. The body must tilt upward, exposing more surface area, disrupting smooth swimming. Even a small improvement in breathing posture can conserve energy. Over generations, subtle changes occur in skull structure. The bones of the snout and face begin rearranging. The nasal openings migrate slightly upward and backward. At first, the shift is minimal. The nostrils are still forward-facing, but sit a bit higher on the skull. This small adjustment allows the animal to take a breath while keeping more of its body submerged, and maintaining hydrodynamic alignment. As millions of years pass, that migration continues. The nasal bones shorten, The skull elongates in ways that support streamlined movement. The nostrils slide further toward the top of the head. Eventually, in later whales and dolphins, they consolidate into a blowhole positioned near the crown. This transformation does not happen suddenly. It is the result of countless incremental variations, each favoring individuals who can breathe with less effort at the surface. You might picture how efficient this becomes. Instead of lifting the snout forward and upward, the animal need only break the surface slightly, exposing the top of its head. Air flows in quickly. The body remains mostly horizontal, ready to descend again with minimal disruption. Breathing becomes integrated into swimming, rather than interrupting it. Inside the skull, other refinements accompany this shift. The nasal passages shorten and straighten, allowing rapid exchange of air. Muscular control develops around the blowhole, enabling precise opening and closing. Water must be kept out. Air must be drawn in swiftly. These adjustments reflect the delicate balance between two environments. The lungs are still lungs, built for atmospheric oxygen. Yet they now serve a creature whose life unfolds primarily underwater. There is something quietly beautiful about this compromise. These animals do not evolve gills. They do not abandon air. Instead, they refine their connection to it. Each breath becomes intentional. A return to the surface is not a failure of adaptation, but a rhythmic necessity. You can imagine the moment of ascent. The body glides upward through filtered light. The water grows brighter above. With a gentle exhale, a mist forms at the surface, followed by a swift inhale. Then the animal descends again, tail guiding it back into deeper blue. This pattern repeats countless times across a lifetime. It becomes as natural as heartbeat. The lungs themselves adapt in subtle ways to support diving. The rib cage grows more flexible, allowing partial compression under pressure. Oxygen storage within muscle tissue increases over evolutionary time, enabling longer submergence. But at this stage, extended deep diving is still limited. The lineage is refining its relationship with surface breathing step by step. As nostrils migrate, the skull reshapes in response. Bones that once framed a long terrestrial snout adjust to support a new airflow pathway. Sensory structures reorganize slightly. Even the facial muscles shift to accommodate a top-mounted opening. Each modification is modest on its own. Together, they redefine the face. If you pause here and imagine holding that evolving skull, you might notice how gradual the transformation feels. The front of the snout shortens. The nasal opening inches backward. There is no abrupt leap to a blowhole, only the steady influence of selection favoring efficient breathing. Meanwhile, swimming grows smoother. With each breath requiring less head lift, the animal conserves energy. Energy saved means more time for hunting, traveling, and nurturing young. Those slight efficiencies ripple through generations. There is nothing you need to track carefully in this process. Just the sense of a body refining itself to move between two worlds. Air above, water below, each breath bridging the divide. As these changes accumulate, the blowhole becomes more than a relocated nostril. It becomes a valve, sealed tightly during dives. Muscles control its opening with precision. The animal surfaces, inhales in a fraction of a second, and closes the passage before descending again. This rapid exchange minimizes vulnerability at the surface and reduces heat loss. Heat regulation too plays a role. Aquatic life draws warmth away from the body more quickly than air does. Over time, insulation increases in the form of blubber, a layer of fat beneath the skin. This supports temperature stability and energy storage. The streamlined head, crowned by a blowhole, emerges from water with minimal exposure. You may feel your own breathing slowing as you imagine this rhythm. Rise, inhale, descend, exhale. A calm repetition shaped over millions of years. There is nothing urgent about it, just adaptation responding to need. The shoreline is now far behind in evolutionary terms. These animals are fully aquatic in behavior, even if their lungs still require the sky. The blowhole represents both continuity and change, a remnant of terrestrial ancestry transformed into an elegant solution for marine life. As this chapter settles into quiet reflection, you can sense how breath itself becomes the thread connecting past and future. The face has shifted, the skull has rearranged. The act of breathing has grown more efficient, more integrated into the fluid world below. And in the stillness between one breath and the next, you may begin to wonder how these increasingly aquatic bodies will refine their senses further, learning not only to breathe at the surface, but to perceive the deep in ways land mammals never could. The water is deeper now and darker too. Sunlight still filters down in soft ribbons near the surface, but below, shadows gather and vision begins to lose its certainty. You glide alongside these early toothed whales as they move through murky coastal seas and broad river mouths. Their bodies are shaped for swimming, their blowholes placed perfectly for swift breaths at the surface. Yet sight alone is no longer enough. In water, especially cloudy water, light bends and scatters. Shapes blur. Distance becomes difficult to judge. And so, another sense begins to rise quietly into prominence. At first, the change is subtle. All mammals produce sounds, whether low grunts, soft clicks, or complex calls. These early whales are no different. Within their nasal passages, air moves past delicate folds of tissue, creating vibrations. Some of these sounds are incidental, others communicative. But in certain lineages, sharper, more focused clicks begin to appear. These clicks are not yet the sophisticated sonar pulses of modern dolphins. They are simple bursts of sound, traveling outward in all directions. Sound behaves differently in water than in air. It moves faster, farther, and with greater clarity through liquid. When a sharp click travels through the sea and strikes an object, it reflects back as an echo. The returning vibration carries information about distance, size, and texture. An animal sensitive to these returning signals gains a remarkable advantage, especially in low visibility conditions. At first, this advantage may be small. A faint awareness of nearby obstacles, a subtle hint of prey movement. But even slight improvements matter. Inside the skull, changes begin shaping this ability. The bones surrounding the ear become increasingly specialized for underwater hearing. Dense structures help isolate vibrations, preventing interference from other parts of the skull. In toothed whale ancestors, a pathway begins forming that allows sound to enter through the lower jaw. Fatty tissues within the jaw conduct vibrations toward the middle ear, acting as acoustic channels. This arrangement enhances sensitivity to echoes returning from the environment. You can imagine how this transforms perception. Instead of relying only on sight, these animals begin to listen to space itself. A click leaves the body, moves outward, touches an unseen fish, and returns as a whisper of information. The brain interprets timing and intensity, constructing a mental map of surroundings. It is not vision in the way land mammals understand it. It is a different kind of seeing, one built from sound. As this ability strengthens, another anatomical feature begins evolving. A rounded structure in the forehead composed largely of specialized fatty tissue. In modern dolphins, this structure is known as the melon. In these early forms, it is less pronounced, but gradually becoming more defined. The melon helps focus outgoing clicks into directional beams, much like a lens focuses light. By concentrating sound waves, the animal can scan specific areas rather than broadcasting in all directions. This focusing ability enhances precision. Instead of vague echoes returning from every angle, the animal can aim its clicks, receiving clearer feedback from chosen targets. Hunting becomes more efficient. Navigation through cluttered environments becomes safer. Murky rivers and dark ocean depths grow less mysterious. The brain plays its role as well. Regions associated with auditory processing expand over evolutionary time. Neural pathways refine the interpretation of rapid echoes. The animal must distinguish between its own outgoing click and the returning signal, often separated by mere fractions of a second. This requires extraordinary temporal resolution. Selection favors individuals whose brains can decode these subtle differences more effectively. You might imagine swimming through dim water, surrounded by faint shapes. A click sounds, an echo returns, revealing a hidden fish just ahead. Another click, another echo, mapping the curve of a rocky outcrop. Gradually, the ocean transforms from an uncertain void into a textured landscape. Sound becomes a brush painting invisible scenes. There is something deeply calming about this sensory expansion. The lineage does not conquer the darkness. It learns to listen within it. Instead of demanding clarity from light, it adapts to the medium as it is. Water carries sound beautifully, and these animals learn to use that gift. Communication likely evolves alongside navigation. Clicks and whistles serve not only for hunting, but for maintaining contact within groups. In murky water, visual signals are limited. Sound travels farther and bends around obstacles. Social bonds strengthen through acoustic exchange. Pods coordinate movement. Mothers and calves remain connected. Individuals recognize one another through distinct vocal patterns. Inside the nasal complex, structures become increasingly intricate. Muscular control allows precise production of rapid click sequences. Air is recycled within the nasal passages during sound production, conserving oxygen while diving. This efficiency enables longer submergence without sacrificing communication or echolocation. As these capabilities refine, the ocean becomes less intimidating. Depth remains vast, but no longer entirely unknowable. The animal carries its own sensing system, projecting awareness outward and receiving it back again. Each click is a question, each echo an answer. There is nothing you need to grasp tightly here. Just the image of sound rippling outward in gentle pulses, touching the unseen and returning home. Now you may feel your own mind quieting as you imagine that steady rhythm. Click, echo, click, echo. A conversation between body and environment. Over generations, individuals with slightly more focused sound beams or more sensitive auditory systems thrive. The melon grows more pronounced. The lower jaw's fatty channels refine. The auditory cortex becomes increasingly sophisticated. These adjustments do not happen in isolation. They intertwine with changes in skull shape, brain size, and social behavior. Eventually, echolocation becomes central to survival in toothed whales, including dolphins. It allows them to hunt in darkness, navigate complex coastlines, and communicate across distance. The ocean, once opaque and uncertain, grows textured and familiar. As this chapter softens toward its close, you can sense how perception itself has transformed. Breath connects air and water. Now sound bridges light and shadow. The lineage no longer merely survives in the sea, it interprets it. And as echoes continue to paint invisible landscapes, you may begin to wonder how this growing sensory awareness will shape the branching paths of whale evolution, dividing those who rely on teeth and sound from those who will follow a different, quieter way of feeding in the vast blue. The ocean is wide now, stretching far beyond the sheltered rivers and coastal lagoons where this journey began. Generations have passed, and the bodies of these ancient whales are fully committed to life in water. Tails power steady movement. Blowholes open and close with effortless precision. Sound travels outward in focused pulses, returning as quiet maps of the unseen. But within this expanding lineage, something subtle begins to unfold. Not a rupture, not a dramatic split, but a gentle branching. Evolution, as it often does, experiments in more than one direction at once. You glide through time and notice that not all descendants pursue the same path. Some continue refining their teeth, sharpening them for grasping fish and squid. Others, however, begin shifting toward a different feeding strategy altogether. The ocean offers many forms of nourishment, and not all of them require pursuit. In certain lineages, the teeth gradually reduce in prominence. They become smaller, fewer, and less central to survival. Meanwhile, the upper jaw begins to develop structures unlike anything seen before in these ancestors. Instead of solid enamel crowns designed to pierce or grip, thin, flexible plates of keratin begin forming along the gums. These plates hang downward like curtains, fringed at their edges. This is the early emergence of baleen. Baleen does not bite, it filters. As these whales swim forward with mouths open, water flows in, carrying with it clouds of small prey, tiny crustaceans, plankton, and small fish. When the mouth closes, the tongue presses water outward through the fringed baleen plates, trapping food inside. This feeding strategy requires a different relationship with the ocean. Instead of chasing individual prey through echolocation and pursuit, these whales harvest abundance in sweeping motions. You can sense how diet shapes destiny here. The toothed lineages refine their sonar abilities, their jaws strong and precise, their brains increasingly attuned to acoustic detail. The baleen lineages, by contrast, grow larger over time, their mouths expanding to accommodate vast volumes of water. The skull reshapes differently in each branch. In baleen whales, the upper jaw broadens, and the lower jaw becomes elongated and flexible to support engulfing feeding techniques. Yet at this early stage of divergence, both branches still share deep ancestry. They breathe through blowholes, swim with powerful tails, and nurse their young beneath the surface before rising together for air. The separation is not a severing, but a branching of possibilities. In the toothed whales, including the lineage that will one day give rise to dolphins, teeth remain central. Conical and uniform, they are suited for gripping slippery prey rather than chewing. Swallowing happens whole. Echolocation continues refining, enabling these hunters to locate fish in darkness or murky water with extraordinary accuracy. Their skulls become asymmetrical in subtle ways, allowing more specialized sound production and reception. The melon grows more defined, focusing outgoing clicks into narrow beams. Meanwhile, the baleen whales relinquish echolocation. Without teeth to seize individual prey, they rely less on precision sonar and more on spatial awareness and large-scale feeding patterns. Their hearing remains acute, but their strategy shifts toward filtering immense quantities of tiny organisms. Over time, some baleen whales grow to enormous sizes, supported by the abundance of plankton in nutrient-rich waters. Their massive bodies move slowly, but with quiet authority through open seas. You might picture this branching like a tree beneath the surface, its trunk deep in time, its limbs reaching outward in different directions. One branch leans toward active pursuit, guided by sound and teeth. The other leans toward engulfment and filtration, guided by currents and seasonal blooms. Both are shaped by the same patient force of natural selection. There is something peaceful in this divergence. Evolution does not demand a single perfect solution. It explores multiple strategies simultaneously. When conditions favor abundance of small prey, filter feeding thrives. When swift fish dominate certain regions, agile hunters excel. The ocean is vast enough to support both. As you drift through this ancient sea in your imagination, you may feel the calm of coexistence. A pod of toothed whales passes swiftly beneath you, emitting sharp clicks, weaving through schools of fish with coordinated precision. In the distance, a larger baleen whale moves slowly, mouth opening wide to take in a shimmering cloud of plankton. Two lineages sharing the same waters, each tuned to different frequencies of survival. Inside their genomes, differences accumulate. Genes controlling tooth development remain active in the toothed whales, while in baleen whales, those pathways quiet down, replaced by genes guiding keratin plate formation. The shift from teeth to baleen represents not a loss, but a transformation of feeding apparatus. Both approaches prove successful across millions of years. Dolphins remain firmly within the toothed lineage. Their bodies become smaller and more agile compared to some of their relatives. Social behavior intensifies. Communication grows complex. Echolocation becomes extraordinarily refined, allowing detailed perception of surroundings. Their teeth remain uniform and numerous, designed for holding rather than slicing. If you allow your breathing to slow here, you may notice how natural this branching feels. No urgency, no competition that erases one path in favor of the other. Simply divergence shaped by environment and opportunity. The ocean offers many niches, and life responds accordingly. There is nothing you need to memorize about this separation. Just the gentle understanding that from a shared ancestry arise distinct futures, teeth or baleen, precision or filtration, speed or scale. Each lineage carries forward elements of the past while embracing new adaptations. As this chapter settles, you can sense how dolphins continue along the path of sound and pursuit, refining their sensory world and social bonds. And you may begin to wonder how these increasingly intelligent, acoustically attuned creatures will shape their communities, their communication, and their minds as evolution carries them further into the blue. The ocean feels open now, vast and uninterrupted, stretching in every direction with a quiet blue patience. You drift beside the lineage that will one day become dolphins, and you begin to notice how their bodies are no longer transitional. They are no longer divided between land and sea. they are shaped by water entirely. Every curve, every surface, every movement reflects a long conversation with fluid resistance. When an animal moves through water, it encounters drag, a constant slowing force created by friction and turbulence. Over millions of years, natural selection favors forms that slip through this resistance with less effort. Gradually, the body becomes smoother, more torpedo-like. The neck shortens externally, reducing protrusions that might disrupt flow. The head blends seamlessly into the torso. Contours soften, sharp angles disappear. You can imagine running your hand along such a body. There are no jutting shoulders, no visible hind limbs. Forelimbs have transformed into flippers, flattened and stiffened, their bones elongated and encased in connective tissue that limits bending. These flippers no longer support weight on land. Instead, they act as stabilizers and steering mechanisms, allowing precise control during turns. Their role is subtle but essential, guiding the body's direction without interrupting forward momentum. Behind them, the spine continues its rhythmic undulation. But now, the tail has fully taken command of propulsion. A broad horizontal fluke spreads at the end, formed from dense connective tissue and supported by powerful musculature in the caudal region. With each downward and upward sweep, the fluke pushes against water, generating lift and thrust. This vertical motion differs from the side-to-side movement of fish, reflecting the mammalian origin of the spine. The entire body participates in the wave, transmitting energy smoothly from head to tail. As these forms refine, bone structure adjusts to support efficiency. Vertebrae in the lumbar and caudal regions become robust and flexible, allowing strong oscillations. Meanwhile, joints in the flippers grow more constrained, minimizing unnecessary motion. Stability increases and energy loss decreases. Over time, swimming becomes not only possible, but elegant. Skin plays its quiet role as well. In fully aquatic whales and dolphins, fur has disappeared. A smooth outer layer reduces friction against water. Beneath this skin lies blubber, providing insulation and buoyancy control. The outer surface remains sleek, minimizing turbulence. In some species, microscopic structures and the shedding of outer skin layers may help maintain a clean, low-drag surface. Each small refinement contributes to hydrodynamic grace. You might picture a dolphin accelerating through open water. There is no visible strain. Muscles contract and release in measured rhythm. The body flexes like a living arc, transferring force efficiently. Speed increases without chaos. In fact, high velocity can feel almost playful, a natural extension of form-meeting medium. Streamlining does more than enhance hunting. It supports migration across long distances. As ocean currents shift with seasons, dolphins and their relatives travel widely, following prey or seeking favorable conditions. Efficiency becomes essential for endurance. A body that wastes less energy in movement conserves more for growth, reproduction, and survival. Even the skull participates in this smoothing. The snout elongates in many toothed whales, forming a narrow rostrum that reduces frontal drag. The blowhole sits flush along the top of the head, opening and sealing with minimal disruption. Eyes are positioned to maintain forward and lateral awareness while preserving streamlined shape. There is something profoundly calming about watching such a body in motion. It does not fight the water, it collaborates with it. Each curve acknowledges the laws of fluid dynamics. Each muscle contraction respects resistance and transforms it into propulsion. Inside the muscles, fibers adapt for sustained swimming. Oxygen storage capacity increases through higher concentrations of myoglobin, allowing dives of meaningful duration. Circulatory adjustments support efficient oxygen distribution. These internal changes complement the external streamlining, creating a system optimized for aquatic life. You may feel your own breath steady as you imagine gliding beside these animals. There is nothing hurried in their speed. It arises naturally from structure aligned with environment. Even bursts of rapid movement during hunting appear fluid rather than frantic. Social behavior also benefits from agility. Coordinated hunting strategies become possible when individuals can turn swiftly and maintain formation. Pods move like living currents, weaving through schools of fish with synchronized grace. Streamlining supports not only survival, but cooperation. As bodies refine, unnecessary protrusions disappear entirely. The remnants of hind limbs are now internal, small pelvic bones embedded within muscle, invisible from the outside. The silhouette is uninterrupted from snout to fluke. Evolution has polished the form through countless generations. The ocean itself influences these shapes. In open waters, sustained cruising efficiency matters most. In coastal regions, maneuverability among reefs and estuaries is crucial. Different dolphin species will later exhibit slight variations in body proportion, reflecting their preferred habitats. Yet the overarching theme remains: smoothness, integration, flow. There is no dramatic moment when streamlining is declared complete. It emerges gradually, like a stone shaped by waves over centuries. Each generation inherits a slightly more refined contour. Each improvement builds upon the last. As this chapter drifts towards stillness, you can sense how speed has become effortless. Not a strain, not a chase against resistance, but a harmonious partnership with water. The body is no longer adapting to the ocean. It belongs to it. And in that belonging, another transformation quietly unfolds, not in bone or muscle alone, but in mind, inviting us next to explore how intelligence and social connection rise within these swift, silver forms beneath the waves. The ocean is no longer only a place of movement. It has become a place of connection. As you glide beside these early dolphins, their bodies perfected for speed and grace, you begin to sense that another transformation is unfolding. One not visible in silhouette, but carried within the quiet architecture of the brain. Over immense stretches of time, brain size in toothed whales increases relative to body size. This expansion is not random. It reflects growing complexity in social behavior, communication, and environmental awareness. The cerebral cortex, particularly regions associated with sound processing and social interaction, becomes more intricate. Folds deepen, increasing surface area within the skull. Neural pathways multiply, weaving dense networks of connection. You can imagine what this means in lived experience. A dolphin does not swim alone by default. It moves within a pod, sometimes small and intimate, sometimes large and fluid. Individuals recognize one another not just by sight, but by signature whistles unique to each member. These whistles function almost like names, allowing dolphins to call and respond across distance. The ocean carries their voices, bending around obstacles, reaching companions out of view. Communication grows layered. Clicks serve for echolocation, mapping the environment. Whistles and burst-pulsed sounds convey social information. Coordination during hunts, reassurance between mother and calf, subtle signals of mood or intention. The brain must interpret all of this simultaneously, echoes from the physical world and signals from the social one. Over time, selection favors individuals who can process and respond to this rich acoustic landscape with flexibility and precision. Social bonds strengthen as lifespans lengthen. Many dolphin species live for decades. Within that span, relationships endure. Mothers care for calves over extended periods, teaching them hunting strategies and social norms. Young dolphins learn not only how to catch fish, but how to navigate the complexities of pod dynamics. Alliances form, sometimes lasting years, particularly among males who cooperate in courtship or defense. There is something deeply calm in this continuity. Generations overlap. Elders remain within the group, carrying knowledge of migration routes, seasonal prey movements, and safe resting areas. Cultural transmission begins to appear. Behaviors passed from one generation to the next, not solely through instinct, but through learning and imitation. In certain dolphin populations, specific hunting techniques become traditions unique to that group. Inside the brain, structures associated with memory grow refined. The hippocampus supports spatial awareness, enabling dolphins to navigate vast territories. Auditory cortices process rapid streams of sound with astonishing temporal resolution. The neocortex integrates sensory input with social context. These neurological developments unfold gradually, shaped by the demands of cooperative living. You might picture a pod moving together through open water, their bodies rising and falling in synchrony. A subtle whistle travels from one individual to another, a gentle reminder of presence. Calves swim close to their mothers, observing, imitating, practicing. Play becomes a crucial part of development. Young dolphins chase one another, toss seaweed, ride bow waves. Play strengthens coordination and social bonds, reinforcing neural connections in growing brains. There is nothing frantic in this intelligence. It does not seek dominance over the ocean. It seeks harmony within it. Problem-solving emerges naturally from the need to cooperate. When hunting schooling fish, dolphins may encircle prey, taking turns darting inward. Coordination requires communication and anticipation of others' movements. Brains attuned to social nuance thrive in such contexts. Sleep itself adapts to social life. Dolphins exhibit a remarkable pattern known as unihemispheric slow-wave sleep, in which one hemisphere of the brain rests while the other remains alert. This allows continued breathing and awareness of surroundings. Within pods, individuals may alternate deeper rest, while companions remain more vigilant. This subtle cooperation extends even into vulnerability. As brain size increases, so does flexibility in behavior. Dolphins demonstrate curiosity toward novel objects and situations. They can learn from experience, adjusting strategies when conditions change. This adaptability proves valuable in dynamic marine environments, where prey availability fluctuates and habitats shift. You may feel a softness in imagining these minds beneath the waves. Intelligence here is not measured in conquest, but in connection. It is the ability to recognize a companion's call, to remember a route traveled seasons ago, to teach a calf how to hunt effectively. It is quiet, sustained awareness. There is nothing you need to analyze in these neural pathways. Just the sense of complexity unfolding gently over time. Brain expansion does not occur overnight. It is the cumulative result of small advantages: better coordination, stronger bonds, improved survival of young. As social structures deepen, communication grows more nuanced. Dolphins may combine sounds in sequences, altering pitch and duration to convey different meanings. While not language in the human sense, these acoustic patterns carry layered information. The ocean becomes filled not only with echoes of prey and landscape, but with conversations carried across currents. The development of intelligence also influences emotional experience. Evidence suggests dolphins possess advanced social cognition, capable of recognizing themselves in reflective surfaces and exhibiting behaviors consistent with empathy. While we interpret these carefully, they hint at rich inner lives shaped by prolonged social interaction. Within pods, hierarchy can be fluid. Cooperation often outweighs rigid dominance. Alliances shift according to context. The flexibility of social roles reflects cognitive sophistication. Brains capable of navigating such dynamics continue to expand in complexity. As you drift through this chapter, you may notice your own thoughts slowing, matching the rhythm of these social swimmers. There is no urgency in their intelligence. It evolves because connection enhances survival. The ocean, once merely a medium for movement, becomes a stage for relationship. Beneath the surface, minds meet and respond, weaving invisible threads between individuals. Intelligence unfolds quietly in blue water, shaped not only by hunting and navigation, but by companionship. And as this social world grows richer, you may begin to wonder how communication itself will deepen further, how clicks and whistles might evolve into ever more intricate patterns, carrying stories of identity and belonging through the vast, listening sea. The ocean is rarely silent. Even in its quietest hours, there is always movement, currents brushing past reefs, distant waves folding over themselves, the soft crackle of tiny organisms drifting in the dark. And within this living soundscape, dolphins add their own voices. Not loud in the way storms are loud, but intricate, intentional, layered. If you could slip beneath the surface and listen as they do, you would hear a world stitched together by sound. In water, vision fades quickly. Light bends, scatters, dissolves into blue haze. But sound travels with remarkable clarity, moving faster and farther than it ever could in air. A whistle released in one direction can travel across hundreds of meters, curving around obstacles, slipping through currents. For dolphins, this property becomes more than useful. It becomes foundational. Among these sounds, one pattern stands out. Each dolphin develops a unique whistle contour early in life, a kind of acoustic signature. It is not assigned by a leader, nor inherited directly in a fixed form. It emerges gradually, shaped by both biology and social environment. Mothers and calves exchange calls frequently in the early months, and calves begin experimenting with sound, refining their own distinctive pattern. Over time, this whistle becomes stable and recognizable to others. You can imagine a dolphin separated briefly from its pod in murky water. It emits its signature whistle, a rising and falling pattern that carries through the sea. Moments later, a familiar whistle responds. Recognition happens not through sight, but through sound. The ocean may conceal bodies, but it cannot easily conceal identity. This form of vocal labeling allows pods to remain cohesive, even when dispersed across large areas. Individuals call to one another during travel, hunting, or social play. They respond selectively to certain whistles, indicating memory and recognition. The brain processes these patterns with remarkable precision, distinguishing subtle variations in frequency and rhythm. As communication deepens, it grows more layered. Clicks continue to serve echolocation, mapping physical space. Whistles and burst pulse sounds convey social information, invitation, coordination, or perhaps even emotion. Dolphins combine sounds into sequences, altering tempo and pitch. While not a language with grammar in the human sense, this acoustic system carries complexity beyond simple calls. Over generations, certain behaviors become shared within specific groups. In some coastal populations, dolphins develop specialized hunting techniques, using sponges to protect their snouts while foraging along the seafloor, or driving fish toward shore in coordinated waves. These behaviors are not purely instinctive. Young dolphins observe adults and learn through imitation. What begins as innovation becomes tradition. You might feel a quiet awe in this realization. Culture, in its simplest sense, is behavior transmitted socially rather than genetically. Within dolphin pods, such transmission occurs subtly but persistently. A calf watches its mother use a particular strategy and repeats it. Over time, the behavior becomes characteristic of that pod, even if neighboring groups hunt differently. Communication becomes the thread that carries these traditions forward. Vocal signals coordinate cooperative hunts. They reinforce alliances. They maintain social bonds across decades. The ocean becomes a vast acoustic archive holding echoes of generations. Inside the brain, regions dedicated to auditory processing and social cognition continue refining. Neural pathways strengthen with repeated use. Memory integrates with sound recognition, allowing dolphins to recall individuals after long separations. Studies suggest they can remember the signature whistles of former companions years later, evidence of durable social memory. You can imagine drifting beside a pod at dusk. The water glows faintly with fading light. A series of whistles passes between individuals, soft and fluid. There is no urgency, no competition in this exchange. It feels almost like a conversation carried by current. There is nothing you need to decode in these sounds, just the awareness that communication shapes community. Each whistle is both signal and connection. Each response strengthens the fabric of the group. As social bonds deepen, inheritance takes on new meaning. Calves inherit not only genes, but acoustic environments. They grow up surrounded by the whistles of their pod, absorbing patterns and rhythms. Their own signature whistles may reflect aspects of those they hear most often. In this way, communication itself becomes a form of lineage. Environmental factors influence this acoustic world as well. In open ocean, where sound travels long distances, whistles may be longer and more modulated. In shallow coastal waters cluttered with obstacles, calls may be shorter, adapted to reduce distortion. The medium shapes the message. Within pods, alliances among males sometimes involve coordinated calling, reinforcing partnership during complex social interactions. Mothers maintain close contact with calves through frequent vocal exchange. Even play is accompanied by sound, bursts of clicks and whistles punctuating movement. You may feel your own thoughts slowing as you imagine this sonic landscape. There is no need to analyze every call. Just sense the continuity of connection carried through water. Over time, communication systems grow resilient. Even when individuals move between groups, they retain their signature whistles, carrying their acoustic identity with them. The ocean, vast though it is, becomes navigable not only through echolocation, but through recognition of familiar voices. As this chapter settles into stillness, you can sense how sound binds these swift swimmers into communities. Intelligence has matured into dialogue. Dialogue has matured into culture. The sea hums gently with memory, and in the quiet that follows a fading whistle, you may begin to wonder how these traditions persist across changing oceans, how migration, memory, and shared roots carry both bodies and voices through the long currents of time. The ocean is not empty. It only appears that way from above. Beneath the surface, it is threaded with invisible roads, currents that sweep warm water toward colder latitudes, seasonal blooms that rise and fade, coastlines that shift gently with time. Dolphins do not wander without direction. Their movements, though fluid and free, often follow patterns that stretch across hundreds or even thousands of kilometers. And as you drift alongside them in your imagination, you begin to sense that travel itself becomes a form of inheritance. Migration in dolphins varies by species and environment. Some populations remain resident within a defined coastal range, knowing every reef and estuary intimately. Others move seasonally, following fish that gather in predictable currents. In open oceans, pods may travel long distances in search of prey, guided by temperature gradients, salinity, and subtle changes in the underwater landscape. These routes are not marked by signs. They are carried in memory. Inside the brain, regions responsible for spatial awareness and long-term recall support this navigation. Dolphins integrate multiple sources of information: echolocation, ocean soundscapes, magnetic cues, and learned experience. The Earth itself produces faint magnetic fields, and evidence suggests that some marine animals can detect subtle variations in these fields. While the mechanisms are still being studied, it is possible that dolphins incorporate such cues into their orientation, blending internal sensitivity with learned landmarks. You can imagine a pod beginning a seasonal journey. The water grows cooler. Prey becomes less abundant in one region and more plentiful in another. An older individual adjusts course slightly, turning toward a familiar current. Younger dolphins follow, not because they understand charts or coordinates, but because they trust the pattern. Over repeated journeys, calves memorize the sequence of sensory impressions. The taste of water at certain depths, the acoustic echoes of distant seafloor ridges, the rhythm of waves against a particular coastline. Memory becomes layered. A single route may be traveled dozens of times across a lifetime. With each passage, details reinforce neural pathways. The hippocampus, deeply involved in spatial memory, encodes these experiences. Dolphins recall where prey was abundant last season, where predators were encountered, where safe resting areas lie. This knowledge is not written in ink, but in synaptic strength. Our navigation blends instinct and learning seamlessly. There is likely an innate orientation towards certain environmental cues, but experience refines that orientation into reliable travel. Just as a human can sense direction within a familiar neighborhood, without consciously calculating each turn, dolphins move through known waters with quiet certainty. Currents play a central role in shaping these journeys. The ocean circulates continuously, driven by wind, temperature differences, and the rotation of the Earth. Warm currents carry nutrients and influence prey distribution. Dolphins learn to ride these currents efficiently, conserving energy. Traveling with a current reduces muscular effort, allowing pods to move great distances with minimal strain. Their streamlined bodies, perfected over millennia, align with these flows naturally. You may feel a calm spreading as you picture this movement, bodies gliding within a larger motion, not resisting but harmonizing. Migration is not a frantic escape. It is a rhythm, repeated season after season. Social transmission strengthens these patterns. Calves accompany their mothers from birth, experiencing migrations firsthand. There are no maps handed down, only participation. By the time a young dolphin reaches maturity, it has traveled the route multiple times. What begins as following becomes knowing. In this way, ocean paths become generational knowledge. In some regions, distinct dolphin communities develop unique migratory patterns, even when neighboring populations occupy similar habitats. This suggests that learning and social cohesion shape routes as much as geography does. Tradition, once again, intertwines with biology. Environmental changes test this memory. When ocean temperatures shift or prey availability alters due to climate variability, dolphins must adjust. Flexibility becomes essential. Pods that can modify routes in response to new conditions are more likely to thrive. Intelligence and social cooperation support this adaptability. Leaders may emerge temporarily during challenging conditions, guiding the group toward alternative feeding grounds remembered from earlier years. There is nothing hurried in these adjustments. The ocean itself changes slowly on seasonal scales, and dolphins respond in kind. A slight alteration in course here, a longer stay in a particular bay there. Over time, new routes may solidify into tradition. Sound assists in maintaining cohesion during travel. These signature whistles keep individuals connected when visibility is limited. Echolocation continues mapping the environment, detecting underwater features that serve as acoustic landmarks. Even subtle differences in echo patterns from seafloor topography can become familiar markers along a route. You might imagine traveling within such a pod, surrounded by quiet clicks and distant whistles. The surface above reflects shifting clouds. Beneath, currents guide the way. There is no written destination, only a sense of continuation. Sleep, even during migration, adapts to movement. Dolphins can rest one hemisphere of the brain while continuing to swim slowly, maintaining breathing and group alignment. In this way, travel and rest coexist. The journey never fully stops. Memory stretches like a map of water, fluid, dynamic, but reliable. It connects seasons, linking present experience to past success. It binds individuals across time as calves grow into adults who then guide the next generation. As this chapter drifts toward quiet, you can sense how migration is not merely movement across space. It is movement across time. Each journey carries echoes of previous ones. Each turn of the body recalls earlier turns. And in the steady glide of a pod following a familiar current, you may begin to wonder how modern dolphins, shaped by ancient memory and present change, navigate an ocean that continues to evolve. An ocean where their long story still unfolds. The ocean you drift through now begins to look more familiar. Continents settle into shapes you would recognize on a globe. Currents establish long, stable circuits. Coastlines harden into bays, peninsulas, and river mouths. And within these waters, the lineage we have followed for millions of years begins to resemble the dolphins you know today. The branching that separated toothed whales from baleen whales continues in quieter ways within the toothed lineage itself. Dolphin families diversify, spreading into different marine environments. Some remain in open oceans, traveling vast distances across pelagic waters. Others settle along coastlines, weaving between reefs and estuaries. A few venture far upriver, adapting to freshwater systems where tides no longer dictate movement. You can picture this diversification like ripples spreading from a single drop. Each population responds to local conditions. In warm tropical seas, certain dolphins develop slender bodies suited for sustained cruising in open water. Their dorsal fins are tall and curved, slicing cleanly through surface tension. In cooler regions, bodies grow slightly stockier, conserving heat more effectively. Blubber thickness adjusts subtly according to temperature. River dolphins, isolated from marine relatives over long stretches of time, adapt in their own quiet ways. In murky freshwater, visibility is even more limited than in coastal seas. Their eyes may reduce in size, while echolocation becomes especially refined. Their snouts often lengthen, helping them probe through sediment for fish hiding among roots and branches. Flexibility increases in the neck region, allowing sharper turns in narrow channels. Each habitat shapes form and behavior. Coastal dolphins may become more accustomed to shallow waters and human proximity, while oceanic species refine endurance for long-distance travel. Prey availability influences hunting techniques. Some dolphins specialize in chasing fast-moving fish in coordinated bursts. Others herd schools toward shorelines, using waves and teamwork to trap them. The skull and jaw continue subtle refinement. Tooth number and spacing vary among species, reflecting differences in prey type. The melon remains central to echolocation, but its shape and acoustic properties adjust slightly according to ecological needs. Sound frequencies used for clicks may differ depending on water depth and clarity. You may sense how evolution does not end with the appearance of a familiar silhouette. It continues quietly, generation by generation. Genetic variations accumulate within populations. When groups become geographically isolated by distance, by currents, by changes in sea level, these variations may eventually lead to distinct species. The process is gradual, often invisible in a single lifetime. Social structures persist and diversify as well. Some species form large fluid groups, numbering in the hundreds. Others maintain smaller, stable pods with strong long-term bonds. Cultural behaviors remain evident. Hunting techniques, vocal patterns, and migration routes differ between populations, even within the same species. Learning and imitation continue shaping community identity. You might imagine drifting alongside a modern bottlenose dolphin, its sleek body reflecting light beneath the surface. It rises effortlessly to breathe, blowhole opening and closing in a fraction of a second. Beneath its smooth skin, the ancient story remains. Pelvic bones hidden within muscle, lungs adapted for diving. A spine evolved from land-walking ancestors. Evolution is layered within its form. Climate shifts over geological time also influence diversification. Ice ages alter sea levels, creating new coastlines and isolating populations. As glaciers advance and retreat, habitats expand and contract. Dolphins adapt accordingly, tracking prey movements and adjusting migratory patterns. These environmental pressures help sculpt the diversity you see today. Inside their cells, DNA continues to mutate subtly with each generation. Most mutations are neutral or insignificant. A few alter traits in ways that enhance survival in specific environments. Over time, these small changes shape coloration, body size, fin shape, and behavioral tendencies. Natural selection operates continuously without ceremony. There is something steady and reassuring about this ongoing refinement. Dolphins are not frozen in evolutionary perfection. They remain dynamic, responsive to changing oceans. Even now, as currents shift and ecosystems transform, populations adjust. Some may expand their range, others may contract. Adaptation is never complete. You may feel your own breathing slowing as you imagine these silver forms moving through contemporary seas. There is no urgency in their motion. They are the product of ancient transformations, yet they remain participants in present change. Modern dolphins also interact with other marine species in complex ways. They compete with predators such as sharks and orcas, cooperate within pods, and influence fish populations through predation. Their ecological roles contribute to the balance of marine systems. Each species fits into a network shaped by both biology and environment. Even within a single species, regional dialects of whistles can emerge. Vocal patterns vary subtly between populations, reflecting social isolation and shared learning. Communication remains fluid and adaptive. The ocean today is vast but not static. Human activities introduce new variables: noise, fishing pressures, habitat alteration. Dolphins respond with behavioral flexibility where possible. Some adapt to boat traffic, altering vocal frequencies to compensate for background noise. Others shift feeding times or locations. Evolutionary change may operate slowly, but behavioral adaptation can occur within generations. As this chapter settles into quiet reflection, you can sense the continuity stretching from ancient shoreline mammals to modern dolphins leaping in sunlight. The transformation has been gradual, patient, unhurried, and it is not finished. Beneath the surface, evolution continues its steady work, shaping bodies and behaviors in response to an ever-changing sea. And as you rest in this thought, you may begin to wonder how the long partnership between dolphins and their environment will unfold in the centuries ahead, as oceans shift once more and memory meets new currents. If you step back for a moment and look at the long arc of time we have traveled, you begin to notice something humbling. For millions upon millions of years, dolphins evolve without ever encountering us. They refine their bodies, perfect their breath, expand their minds, and weave their cultures beneath the waves long before human eyes ever meet theirs. And then, only very recently in geological terms, our paths cross. You can imagine the first coastal humans standing at the edge of the sea, watching sleek shapes break the surface offshore. To them, dolphins may appear almost mythic, fast, graceful, social, and strangely familiar in their mammalian rhythm of breath. To dolphins, humans are something new in the acoustic landscape, a different kind of swimmer, a creature that moves awkwardly in water but carries tools and vessels that slice across the surface. The timeline is striking. Modern dolphins have been evolving in recognizable forms for millions of years. Homo sapiens, in contrast, appear only in the last fraction of that span. Our shared history is a brief overlay on a much older story. And yet, in that short overlap, many interactions unfold. In some coastal regions, humans and dolphins develop cooperative relationships. Historical accounts describe dolphins driving fish toward fishermen's nets, responding to subtle signals and receiving part of the catch in return. While the exact origins of such cooperation are complex, it suggests an ability on both sides to recognize patterns and adjust behavior accordingly. Dolphins, with their keen perception and social flexibility, respond to repeated human actions. Elsewhere, dolphins approach boats with curiosity, riding bow waves generated by moving vessels. This behavior is not new. It reflects their attraction to pressure waves and opportunities for effortless travel. Boats simply provide another moving surface to interact with. To a dolphin, the physics of a bow wave offer a playful ride, requiring little energy while maintaining speed. Human observation of dolphins grows more systematic over time. Scientific study begins examining their intelligence, social structure, and communication. Researchers listen to whistles through underwater microphones, tracking migration patterns with tags, documenting cultural behaviors. The more closely we observe, the more complexity we uncover. There is something gentle in this exchange of awareness. Dolphins do not evolve because of us. Their core adaptations, echolocation, streamlined bodies, social cognition, are ancient achievements. Our presence may influence certain behaviors at the margins, but their lineage remains rooted in far deeper time. In modern oceans, however, our activities create new challenges. And fishing practices can reduce prey availability. Noise from ships and industrial activity alters the acoustic environment. Dolphins, whose perception depends so heavily on sound, must navigate increasingly crowded soundscapes. Some populations adjust by altering vocal frequencies or timing calls differently to avoid interference. Yet, even in the presence of human influence, dolphins continue patterns established long before our arrival. Pods maintain social bonds. Calves learn from mothers. Migration routes persist. Evolution does not halt in response to a new species. It absorbs new variables and continues. You might imagine a dolphin surfacing near a quiet shoreline at dusk, exhaling softly. A human stands nearby, watching in stillness. For a brief moment, two intelligent mammals share the same air. The dolphin's lineage stretches back through ancient seas and vanished coastlines. The human's lineage stretches back across savannas and shifting climates. Their encounter occupies only a flicker of evolutionary time. In some regions, dolphins show behaviors that suggest tolerance or even interest in human presence. They approach divers, investigate unfamiliar objects, and sometimes assist swimmers in distress. While such stories must be approached carefully, they reflect the cognitive flexibility of dolphins. Curiosity is not unique to humans. At the same time, caution remains wise. Dolphins are wild animals shaped by ecological roles as predators and social beings. Their behaviors respond to context, not sentiment. Respectful distance allows both species to coexist without undue stress. Inside their bodies, nothing fundamental changes because humans appear. Blowholes open and close as they always have. Tails rise and fall in steady rhythm. Brains process echoes and whistles, not human languages. Their core identity remains anchored in ancient adaptation. You may feel a quiet perspective settling over you. The span of human-dolphin interaction, though meaningful to us, is brief within the ocean's history. We are newcomers to a story already deep and intricate. Yet our role now matters. Conservation efforts emerge from growing understanding. Marine protected areas seek to preserve habitats. Regulations aim to reduce bycatch and limit harmful noise levels. Science informs policy, attempting to align human presence with ecological continuity. Dolphins remain shaped primarily by the millions of years before us, and their bodies carry the memory of land-walking ancestors. Their minds carry traditions older than recorded history. Our influence is recent, a whisper across a long timeline. As this chapter settles into calm reflection, you can sense the humility in recognizing that we are participants, not authors, in this evolutionary narrative. The ocean holds stories far older than our own. And as you rest with that awareness, you may begin to wonder how the next chapter of this shared history will unfold. How ancient adaptations and modern realities will continue weaving together beneath the wide, patient sea. If you linger here at the edge of this long journey, you begin to sense something steady and reassuring. The story has not ended. It has only reached the present moment. Dolphins glide through today's oceans with bodies shaped by ancient rivers and vanished coastlines. But evolution has never paused. It continues quietly, cell by cell, generation by generation, beneath the surface of awareness. Inside every dolphin swims a living library written in DNA. This genetic code carries instructions refined across millions of years, yet it is not frozen. With each birth, tiny variations appear. Most are subtle, barely noticeable. Some alter nothing important at all. A few shift traits in ways that may, over time, influence survival. These variations do not announce themselves. They whisper forward into the future. You can imagine a newborn calf surfacing beside its mother for the first breath. Its body resembles hers, yet no two dolphins are perfectly identical. Slight differences in coloration, body proportion, immune response, or vocal pattern emerge naturally from genetic variation. If an environmental condition favors one variation over another, that trait may spread gradually through the population. The oceans themselves continue to change. Currents warm or cool in response to shifting climates. Storm patterns intensify or ease. Prey species move in response to temperature and nutrient cycles. Dolphins respond in turn, adjusting migration timing, altering feeding strategies, exploring new territories. Behavioral flexibility often precedes genetic change, allowing populations to adapt quickly within a lifetime. Over longer spans, natural selection may favor individuals better suited to new conditions. A slightly thicker blubber layer may aid survival in cooler waters. A subtle shift in vocal frequency might improve communication in noisier environments. Enhanced resistance to certain pathogens may spread through a population exposed to new diseases. Each change is modest. Yet across centuries, modest adjustments accumulate. There is something calming in recognizing that adaptation is continuous. Dolphins are not relics of a distant past. They are participants in a living, dynamic ocean. Their evolutionary story did not conclude with the emergence of echolocation or streamlined bodies. It unfolds still, quietly, without spectacle. Modern genetic studies reveal how closely related different dolphin populations are and how isolation can shape divergence. When groups remain separated by geography or behavior for long periods, their genetic differences increase. Over time, this can lead to the formation of distinct species. The process is slow, often invisible to a single generation, but the potential remains present. You might picture a pod inhabiting a remote stretch of coastline, rarely encountering others beyond its group. Over many generations, small variations unique to that population accumulate. A new dialect of whistles emerges. Subtle anatomical differences appear. If separation persists long enough, these distinctions may become profound. At the same time, Gene flow between populations maintains continuity where interaction occurs. Dolphins traveling between regions may carry genetic material that blends populations together, preserving shared ancestry. Evolution balances divergence and connection, much like the tides balance isolation and exchange. The oceans themselves have shifted dramatically over Earth's history, and they will continue to do so. Ice ages have lowered sea levels, exposing continental shelves. Interglacial periods have raised them, flooding coastlines. Marine ecosystems have expanded and contracted repeatedly. Dolphins have persisted through these transformations, adapting to altered habitats. Human influence adds a new layer to this ongoing story. Climate change, pollution, and habitat modification introduce pressures that did not exist in earlier eras. Dolphins respond behaviorally where possible, adjusting ranges, modifying feeding times, altering vocalizations in response to increased noise. Whether genetic adaptation can keep pace with rapid environmental change remains an open question, one that scientists study carefully. Yet even in the face of uncertainty, the long arc of resilience is evident. Dolphins have navigated extinction events, shifting continents, and dramatic climatic fluctuations. Their lineage has endured because it is flexible, intelligent, and socially cohesive. You may feel a quiet humility in considering this continuity. The surface of the ocean reflects moonlight, but beneath it, generations rise and fall. Calves are born, grow, form alliances, and eventually give way to new young. DNA passes forward. Behaviors are taught and remembered. Migration routes adjust slightly with each season. There is no final chapter in evolution, only ongoing variation and selection shaped by environment and chance. The ocean remains a laboratory of subtle change, and dolphins remain among its most elegant participants. If you allow your thoughts to soften here, you can sense how peaceful this realization is. Nothing in nature stands still, yet nothing rushes beyond its capacity. Adaptation unfolds at the pace of life itself. Sleep reminder here. Let your breathing slow as you picture a dolphin gliding just beneath the surface, its silhouette steady against the shifting light above. There is nothing you need to solve, no future to predict. The story continues whether or not you follow each detail. As this journey gently comes to a close, notice how wide and still the ocean feels. So many lives unfolding quietly beneath the surface. You don't need to remember each stage of their long transformation. They have already carried it forward. If you enjoy these slow explorations, you can support the channel in any small way that feels natural, so others can find this calm too. But right now, there is nothing to decide and nowhere to go. Let your thoughts soften, your muscles relax, and the night carry you onward, one peaceful breath at a time.